Vertex, axis of symmetry, X intercepts of a quadratic equation. These things can be tough, especially when you're first learning it. So I wanted to create this very easy to understand tutorial showing you an example of how to do these types of problems. So without further ado, let's go ahead and jump into an example, and I'll show you a very easy to follow guide that you can use to do any of these types of problems all on your own. Let's get it. Sketch the graph of the quadratic function, identify the vertex, axis of symmetry, and x-intercepts. So now this example, we are given a quadratic function, which is in the kind of standard form. And again, like I said before, depending on what textbook you're using, they might define standard form differently than the way I'm defining it. But the way I learned it is standard form is this ax squared plus bx plus c. Some textbooks consider what I have been calling the vertex form to be standard form. So be careful with that. Make sure you check that in your textbook. Check that with your teacher. Make sure you know which kind of terminology you should be using in your class. But it's in this form, this ax squared plus bx plus c form. Now what we want to do is kind of think about what our a and b and c values are. Well, the a is always going to be whatever the coefficient of your x squared term is. So in this case, we kind of have an implied a value of 1. Whenever there's no coefficient in front of your x squared or your x term, you can just assume that the coefficient is 1. Then we have a b value of 2, and then we have a c value of 1. So once you've kind of identified that you have it in this ax squared plus bx plus c form, identified what your a, b, and c are, you can pretty easily find the vertex from there. All you really have to do is just use the equation, basically, that the x coordinate of the vertex of a quadratic equation, quadratic function that is in this form, is just going to be negative b over 2a. So in this case, negative 2 over 2 times 1. Now we can just simplify that down. Negative 2 over 2 times 1 is 2. Negative 2 over 2 is negative 1. So the x coordinate of our vertex is going to be x equals negative 1. Now to find the y, all we have to do is take x equals negative 1, plug it into our equation here. So we're going to get y equals negative 1 squared plus 2 times negative 1 plus 1. Okay, so whenever you're plugging in an x value into an equation like this, you're basically just replacing all the x values with whatever this number is. And then make sure you put it in parentheses like that. Just kind of as a first step, I think it's generally a good idea to just literally take your x out and put in whatever number you're trying to put in there, and put it in parentheses just like I did here. And the reason that's important is the negative sign is going to behave differently if you're putting in parentheses or if you're forgetting those parentheses. Because the squared now, if you have negative 1 all in parentheses squared, like we have here, negative 1 times negative 1 is positive 1. So anything squared is just that number times itself. So this is like negative 1 times negative 1, which is positive 1. Okay. If you forget the parentheses and you just write negative 1 squared, the squared is only being applied to the 1. 1 squared is 1, so you still would have negative 1. So the parentheses do make a difference here. The sign is going to be different if you forget to write those parentheses. So just be careful with that whenever you're plugging x values into a function like this. Okay, then we're going to have 2 times negative 1, which is negative 2, plus 1. 1 plus negative 2 is like saying 1 minus 2 plus 1. 1 minus 2 plus 1 is 0. 1 minus 2 is negative 1. Negative 1 plus 1 is 0. So our x coordinate of our vertex is negative 1. The y coordinate of our vertex is 0. So our vertex is at negative 1, 0. Okay. From there, we can talk about our axis of symmetry. Once you have your vertex, your axis of symmetry is always just going to be x equals whatever the x coordinate of your vertex is. So x equals negative 1. And then x intercepts. So again, just like we've done in prior examples, to find the x intercepts of a function, you just set it equal to 0. So we're just going to get 0 equals x squared plus 2x plus 1. And then solve for x from there. So probably the best way to solve this one would be to factor it out. This can be factored out as x plus 1 times x plus 1, because this would FOIL back into x squared plus 2x plus 1. And then we can set each of these parts equal to 0 separately, because if either factor is 0, 0 times any other number is also 0. So of course, these two equations are exactly the same, so we really just need to solve one of them. We get x equals -1. So basically, we only have one x-intercept in this case. This one will also give us x equals -1. We only have one x-intercept at x equals -1, and we know that our vertex is at -1, 0. So now to sketch all this, we can start by just drawing our axes here. So like I said, our vertex is at -1, 0. So we go to x equals -1, y equals 0. So our vertex is right there. And then we have only one x-intercept at x equals -1, which is exactly what our vertex is. So that's what we would expect whenever we're only getting one x-intercept on a quadratic function. That tells us basically that our vertex is on the x-axis. So just kind of a shortcut there, going back here, as soon as we found that our vertex occurred at a y value of 0, that tells us that our vertex is sitting on the x-axis. If the vertex of a quadratic function is sitting on the x-axis, that means that's the only point where it intersects with the x-axis. So that's kind of a shortcut. We didn't really need to do this kind of solving for the x-intercept right here, because our vertex actually told us that we only had one x-intercept and that it was at x equals -1. So then from there, we want to just kind of think about what direction this parabola is going to go. Is it facing upward or facing downward? Since our a value is +1, it's a positive number, that tells us it's facing upward. So it's just going to go up. And that's not a great sketch because it should go through this point 0, 1 right here. I kind of missed the mark there, but that should be a pretty good sketch of our quadratic. And then we definitely want to make sure to, label our axes and all that. Make sure it's correct there. But that should be a pretty good sketch. So that's about it. Hey, look at that. You made it to the end of this guide. Hopefully you're feeling a lot better about how to do these types of problems, but trust me, you don't want to stop your learning journey there. Go click on that video right there. We'll keep learning this with another practice problem so that you can really nail down this topic and ace it on your next test. By the end of that, you should hopefully know this topic like the back of your hand.